To remotely control an espMouse, you first need to write a web app to transmit accelerometer data from the device you plan to use as a remote for your robot. For this tutorial, I'll use my Android smartphone, but since we're using a web-based setup, something that's going to connect via Wi-Fi, you could just as easily use an iPhone, an iPad, a Windows phone, a BlackBerry, or even a Mac or Windows laptop. It would be really handy if we could write our code on a regular computer because it has a keyboard and a big screen, and then test it immediately on whatever device you plan to use. Uh, this is easy to do with Cloud9, a free web-based IDE. To go to Cloud9, just type c9.io. You can sign up using either Bitbucket or GitHub. I chose to use Bitbucket, so when I click sign in, I can just click on Bitbucket, and they actually created my Bitbucket account using my Google credentials. So I can just click on Google, and then I don't have to remember any extra usernames or passwords. Now that I've signed in to Cloud9, I'm going to create a workspace. I'm going to name it espRemote, and the description is just a web app to remotely control a robot. I'm going to make it private so nobody sees my super secret code, and then I'm going to choose an HTML5 template. If you're really nerdy, you can even use Bitbucket to back up your code, but for now I recommend just copying and pasting the code you make in Cloud9 to Bitbucket like we've been doing with the Arduino code. Then just click Create Workspace. Once you've created the workspace, double click on the Hello World demo program, and then click on Preview and Live Preview File. This will launch your app in this small window right here. Let's go ahead and refresh it. Oh, there it is. It just popped up. And then we can click on this button to open it in a new tab so that it takes up the full screen. You see here I can hit click me, and there we go, it says Hello World. To make sure everything is working as it should, I suggest opening a new tab and going to goqr.me and then copying the URL from this tab into this text box. That will create a QR code that you can then scan with your phone. To test the page on your phone, open a QR code scanning app or barcode scanning app. I use barcode scanner, and just scan the QR code and then open it in a web browser. It'll try to take you to that web page, but first it's going to ask you to sign in. Again, I can sign in with Bitbucket, which will allow me to sign in with Google. And here you can see the Hello World app is working. Now it's time to start working on our remote control web app. Create a new file by clicking File, New from Template, HTML file. That should give you a bare bones web page just like you see here. If you're unfamiliar with what you see, I suggest you take a break and study some of Khan Academy's computing programming courses, where you can learn JavaScript and HTML and CSS, or you can go to Codecademy, where you will see HTML and CSS and a JavaScript course as well. Both websites offer those courses for free. For now, I'm going to come back and start working on the web app, and before I do that, I'm going to close this little window here just to give us a little more screen real estate. To begin with, we're going to make sure that your device has an accelerometer and that we have access to it. To do this, the first thing we're going to put on our screen is accelerometer status unknown. And then we're going to wrap this in div tags that have an ID so that we can programmatically change the text that's displayed here. I'm going to say DM event for device motion event. And then the tag right here should actually come at the end over here. Alright, next we're going to add a call to the init function right here, onload equals init. And what this is doing is when the web page loads, it's going to call this function. It's going to trigger that function. Now, we don't have any such function yet, but we'll make one right now. In between the head tags here, we're going to create some script tags. And the function we're going to create is init. And it's going to have one condition, and it's going to check for an accelerometer by saying window device motion event, or listen for device motion or movement in window. If this resolves to true, basically if it detects an accelerometer, then what we want to do is change the text that is in our web page to something else. So I'm going to get the element that we've created, this DM event right here, this tag, by typing DM event right here, and then I can change the HTML that's between these tags by saying .inner HTML and setting it equal to whatever I want it to be. So here we would say accelerometer supported. Otherwise, I'm going to say document get the same element and change it to accelerometer not found. You'll notice here the else tag isn't lined up with the if, or the else portion of this isn't lined up right below the if. To fix that, I could just use the delete key or the backspace key, or I can hit Command Shift B for beautify. The other way to do that is to go to Edit, Code Formatting, and then I can do the Auto Select Formatter, and this shows you the shortcut to make that happen. Now you can see these are lined up. Now, before we do anything else, let's go ahead and save our page as remote.html. And now let's test it out. And here you can see it says accelerometer supported. I'm going to close all these tabs that we have open up here and open this one in a new tab and go back to goqr.me, copy this URL into here, and now I have a new QR code to scan. To test it out, do just like we did before. Scan the QR code and navigate to it. And now you can see that here the accelerometer is supported on my phone as well. To see the values from your accelerometer, go to your init function and we're going to add some curly braces for the true part of the if statement. Right now, only this line of code will be executed if the condition's true, and only one line of code will be executed unless you add these curly braces. Now I can put as many lines of code in this part as I want, and they will all be executed. So I'm going to say window dot add event listener, and then it's going to be the device motion that we listened for, and we're going to call the device motion handler. Now we don't have a device motion handling function yet, so towards the bottom of our script section we're going to create one. Function device motion handler, and then it's going to take the event data as an argument, and I am going to grab the accelerometer data from this event data argument. There we go. So now we have something we can use to get information from the accelerometer. To make this information visible, we're going to temporarily modify the inner HTML of some div tags. So to do that, we're going to do just like we did with the accelerometer information we were looking for earlier, the div tag for the accelerometer supported and whatnot. These commands will modify what is displayed on our web page provided tags exist with the corresponding IDs. Right now there aren't any, so let's add some. Between the body tags, right below the accelerator not found message, add div ID equals X. And do the same for Y and Z. Now, save your program and then preview it. And you should see accelerometer values here. You can see they're changing ever so slightly for the X and the Y. Using the same method I showed you before, pull up the web page on your phone. We're going to do this so that you can try and figure out which axes you need to use to control your robot. So here, if I tilt my phone forward, you can see both X and Z change. I'm looking for the axis where when my phone is tilted so that it's in this position, kind of straight up and down. I'm looking for something that's around 0, but then gets bigger when I tilt it forward and gets smaller when I tilt it backward. And as you can see, that would be the Z-axis. Next, so that's going to be my power axis. Next, I need to figure out which axis gets bigger when I tilt my phone to the right, and then gets smaller and turns negative when I tilt it to the left. And as you can see, that's my y-axis. If you're using an iPhone or a BlackBerry or even different models of Android devices, these axes might be different. So go ahead and take note of which axis you are going to use in the next step.
Now that we know which axis to use, we can remove the code we just added that deals with capturing and displaying accelerometer values. So I'm going to get rid of these div tags here, and I'll get rid of these lines of code that modified those div tags. And instead we're going to display the power, which I'm going to round. We don't need the accelerometer value to the 18th decimal. And the z-axis is what we're going to use for power. And then we're going to need to do the same thing for steering. And I forgot to put at the beginning of each of these, you can see there's a little angry warning symbol over here. That's because I didn't put a var in front of here. These are variables that haven't been declared yet, so we're going to declare them and set them at the same time. And then once I do that, I'm going to go ahead and write some lines of code to modify an element that we haven't created yet, but we'll call it power. And we'll give it a label as well. So here's the text that we'll show. And then the actual value. So just to make sure you understand this, this is text that will be displayed, and you can tell because it's in quotes. And then here, this refers to the variable that we created up here and we set equal to the accelerometer's z-axis. We need to do the same thing for the steering. And then to have a tag for these two lines of code to modify, we need to go ahead and add those down here. So I'm just going to say div id equals power and now if we save our web app and then preview it, we can see the power and the steering levels here. You can see they're not correct because they're being displayed for my computer's accelerometer.
But if I view that web page on my phone, it behaves as expected. Tilt it forward, the power goes up. Tilt it back, the power goes down. Tilt it to the right, the steering goes up. And tilt it to the left, the steering goes down.
One of the problems we have right now is that the power and steering levels are too small. If we're using parallax motors, we need values that range between 0 and 200, and the SM-S4303 servos need values that range between 0 and 500. To make that happen, all you need to do is multiply
by an appropriate number right in here. So I'm going to say times 60. That works well for me on my device. If you're using a different device, this might have to be a negative number to invert the axis as well. Once you've made the appropriate changes to your program, go ahead and test them out on your phone. Here you can see the power level I have does go all the way up to 500 and down to 500, and the same with the steering. Next, we need to convert the power and steering levels into something that can be fed into our motors. To do this, go to the bottom of the device motion handler function and add var left motor equals power plus steering, and var right motor equals power minus steering. Then we're going to add one more line that's send get request. And the way get requests work is you say a parameter, the name of a parameter. So we're going to create one that's L. We're going to set it equal to, and then put the left motor power, and then we're going to send another one for the right motor, but we're going to separate them with an ampersand. So the right motor equal to right motor. So this is going to send a request to a web page that's hosted by the Node MCU, but we don't have a send get request function created yet, so we're going to go ahead and do that down here. Function, and then send get request. It's going to take some data, a parameter, so we're just going to call that data, and then we're going to say var request. We're creating a request object, XML HTTP request. And then we're going to create the message we're going to send, which is going to be http://192.168.4.1, which is the IP address of the Node MCU when it's in AP mode or access point mode. Then we're going to say go to the remote control page, and then we're going to, and the remote control page is a kind of a pseudo page that we're going to create on the Node MCU side of or the Arduino programming side of this control system. And then we're going to put a question mark, which is just how GET requests are structured. After you list the page, you put a question mark, and then you put the parameters you're sending. So we're going to say plus, and then data. So that's the information we got from here, which is this information right up here. So this is basically just the left and right motor data. And then we're going to concatenate that with, or add to that, an ampersand and t equals, and then we're going to put time. Scroll here so you can see it all. New date, and then dot get time. And we're doing this so that each time we send the GET request, it's actually sent. Otherwise, what happens is it gets cached, and then the page doesn't actually send. Then we're going to say request.open, and we're going to set it as a get request as opposed to a post request, and then the message, and then I put true here, and what the true signifies is that this is going to be an asynchronous request. We're not going to wait for the answer. The next line is going to set a div tag, which we are going to call message, MSG, and we're going to set that to the message we created in line 2 here. And once we're done with that, we can go ahead and send the request. One last thing we need to do is create the div tag that will be modified. So right down here, I'm going to say div, and then I'm going to give it an ID of message. Close it, and then put some text in there just to start with. Once you've done that, go ahead and save your code, and then test it out. And here you can see there's a message being sent to this IP address, this web page, with these parameters: a left motor with a power level of 580 whatever, and then a right motor with the power levels up in that area too, and then the time, which is constantly going up. Right now these parameters don't make sense because I'm viewing them on my computer. But if you view the page on your cell phone, you'll see that the left and right motor values behave as expected. Here the left and right motor values are close to 0, but when I tilt the phone forward, they both go up. And when I tilt the phone to the right, the left motor goes up while the right motor goes down. It becomes negative. If I do the reverse, the left gets negative and the right gets positive. And when I tilt it back, they both go negative. At this point, your web page would work if there was a program on the Node MCU to receive the data and turn it into instructions for the motors. However, you would eventually notice a delay that would progressively get worse as you continue to control your mouse. That's because the call to the send-get-request function is at the bottom of the device motion handler right here. And the problem with that is the device motion handler fires many times a second. It's too many instructions for the Node MCU to keep up with. Eventually it would be following instructions you'd sent several seconds earlier. To prevent this, we're going to add 2 buttons and 2 new functions to start and stop the messages and send them less frequently. Below the send-get-request function, we're going to add the start function. And we're going to create a variable of sorts to keep track of the command that we're executing right now. So this is the refresh interval ID. What we're going to do is we're going to set an interval for how often we're going to call the send-get-request function. And so right up here, this send-get-request, we can just cut that, and I'm going to use Command X. On a Windows machine you would use Control X. And then I can click right in between these curly braces and press Command V for paste, or Control V if you're using a Windows machine. And I need to make sure I delete this last semicolon here, because that was the end of the command, but now the end of the command is going to come right after that last parenthesis. And then in between the curly brace and the last parenthesis, I'm going to put a comma and 200. This defines how many milliseconds must pass before the function is called again. And that's all there is to the start function. You'll notice here there's a little warning indicator, and what's happening is it's upset that it sees left motor and right motor in this line of code, and that's because those two variables were declared inside this function. If they're declared inside this function, it means they only have scope. They're only recognized inside this function. So what we have to do is actually copy this variable. We'll go to the very top of our script and paste it, indent it appropriately, and set it equal to 0. And do the same thing with the right motor. And then, now that I've done that, I need to get rid of this var keyword inside this function. And now, it shouldn't be complaining about the left motor and the right motor anymore. It is upset that I didn't put a var in front of this refresh interval ID, but that'll actually make the script not work. The way we have it written here is correct. Next, it's time to create the function to stop the send get request function from being sent every 200 milliseconds. To do that, we write clear interval, and this is where the refresh interval ID comes in, because that's how it knows what to clear. And then we're going to send one more request, and that is to set the left motor equal to 0 and the right motor equal to 0. So now that we've set both of those variables, we have to send the get request one last time. There we go. Just going to copy that, paste it right down here with a semicolon at the end. Once I've done this, I need to create some buttons to trigger the start and stop functions. So I'm going to go down to the body tags here, and at the bottom of the body I'm going to say button type equals button, and on click equals start, and then the text inside the button will be start, and I'll do the exact same thing for the stop button. At this point, the web app portion of your code should be finished, but you can't test it until you host it from your Node MCU.